Hello, I will now be presenting my project, Increasing Magnetic Field Intensity through Improved Toroidal Field Coil Design. Firstly, toroidal field coils are used along with a power source as an electromagnet, which uses the magnetic field that forms as a result of the current passing through the wire. The problem that my project is solving is that tokamaks are lacking in consistency to create a magnetic field intensity great enough to sustain nuclear fusion reactions for an extended period of time so that the critical point can be met. And the design goal that my project is focusing on is to create toroidal field coils through altering maximum coil width and maximum wire length to produce an efficient and scalable model so that the greatest magnetic field intensity can be met. The variables were controlled in this experiment so that the independent variables could include the maximum coil width and maximum coil length, whereas the dependent variables included the magnetic field intensity, or also known as Tesla. From my research, I learned that altering the length and width of toroidal field coils changes the density of the magnetic field lines, which will in turn create a unique magnetic field, which can lead to a greater magnetic field intensity. Also, toroidal field coils are used in nuclear fusion reactors known as tokamaks, along with colloidal field coils and a central solenoid. Now, the purpose of the toroidal field coils is to propel the fuel of tritium and deuterium so that great enough speeds and temperatures can be met that fusion can be induced, which will in turn generate electricity. To implement the design goal of the project, which was creating an efficient model of toroidal field coil which would produce the greatest magnetic field intensity, this was accomplished through the creation of 9 separate 3D models that were made using Tinkercad software. And after assembling the toroidal field coils with the coiled wire, tests were then performed that would allow me to determine the model that outputted the greatest magnetic field intensity. And this was accomplished by using a Tesla meter, which would be able to read its magnetic field intensity. And a complete materials list can be found in the research plan. A detailed procedure can be found here as well as in the research plan. An example of how my project works is demonstrated here. When looking at this graph, we can see that of the toroidal field coils with a length of 5 centimeters, the model with a width of 1 centimeter performs the greatest compared to the models with widths of 0.5 and 1.5 centimeters. When looking at this graph, we can see that of the toroidal field coils with the length of 10 centimeters, the model with the width of 1 centimeter performs the greatest compared to the models with the widths of 0.5 and 1.5 centimeters. And when looking at this graph, we can see that of the toroidal field coils with the length of 15 centimeters, the model with the width of 0.5 centimeters performs the greatest compared to the models with the width of 1.5 and 1 centimeter. Now this graph demonstrates the average of the magnetic field intensity of all 9 models of toroidal field coil. We can see that the toroidal field coil model that incorporates a length of 10 centimeters and a width of 1 centimeter is seen to generate the greatest magnetic field intensity out of all 9 models. When analyzing the data, I found that a change in the length and width both affect the magnetic field intensity. However, they alter the different dimensions, leading to different outcomes and making them independent from each other. Additionally, through a one-way ANOVA analysis, the 10 centimeter by 1 centimeter toroidal field coil proved to be the most efficient, and this can be proven through the p-value of 0, which indicates that it is undoubtedly significant. In conclusion, toroidal field coil with the dimension of 10 centimeter and 1 centimeter width proved to be the most significantly more efficient compared to all other designs. The applications of this project can be seen in the implementation in the aforementioned use of creating an efficient nuclear fusion reactor by using consistently and more efficiently being able to produce more energy than the amount of energy used to induce the reaction through this more effective toroidal field coil design. Additionally, I recommend for future studies on this topic that the method could be used to improve by testing superconductors rather than normal conductors, and this would allow for a greater magnetic field intensity due to the lack of resistance. Additionally, the coils can be implemented in a functioning tokamak, and this will design a more realistic setting. The abstract can be found alongside the paperwork. Thank you, judges, for your time.